This is the second part of the higher tier paper from Wednesday 4th of November 2015, and it's a non-calculator, and it's just the last four questions 19 to 22. They tend to be the harder ones, so let's give it a go and finish this off. Okay, we've got this question. We've got a cone on top of a hemisphere, and let's see what we've got to do. The radius of the hemisphere is equal to the radius of the base of the cone. Cone height is 10 centimeters. Volume of the cone is 270 pi centimeters cubed, and work out the total volume of the solid shape. So we know the volume of the cone. We need then to work out the volume of the hemisphere. Add them together. So fortunately, we've got some formulas for the volume of the cone and the volume of a sphere or hemisphere. So let's go and get those first. They're at the beginning of the paper. So here's our formula sheet. I think it's the second page. And we want this formula here, volume of a sphere, and we want this formula here, volume of a cone. So let's just take those a minute and pop them in. There's our volume of a sphere. And we need to get the cone. Let's get that one. And there's our volume of a cone. Okay, we've got something to go on now then. Now the first thing is, if we look at this sphere, we haven't got the whole sphere, we've got half of the sphere. So instead of 4/3, straight away we can cross that 4 out and call it 2/3. 2/3 pi r cubed. Okay, volume of cone, third pi r squared h. Okay, what do we know? The volume of the cone is 270 pi centimeters cubed. So if we put that into this, we know the height is 10. We should be able to find the radius. And let's see what that does then. So we'd say this. Pi r squared h, and h is 10, so let's put that in there. Well, I can see if I divide both sides by 10, that 0 is going to disappear from there. I've got 27. If we go 3 times 27, that'll get rid of this third. So 3 7s are 21, 3 20s are 60, 60 and 21, 81. 81 pi equals pi r squared. Now, these pi's are going to disappear. We can divide both sides by pi. 81 equals r squared, so r must be 9 in the square root of 81. So that's our radius. So now we can work out the volume of this hemisphere by putting our value of r in. So we can say hemisphere 2/3 pi r cubed. Just do it slightly different. 2/3 pi 9 times 9 squared. I can then cancel this 3 with this 9 here. So that's 6. 2 times 3 is 6. And 9 squared was 81, wasn't it? So it's 6 times 81. So let's just work that out. We can do it this way. 81 times 6. 6 ones are 6. 6 eighths are 48. 486. So this one equals 486 pi. So we just add that together, don't we? You have to add it to the volume of the cone. The volume of the cone was 270. So total volume equals 486 plus 270. It's going to be in terms of pi. I'll just do it down here. Seven and 8, 15. 4, 5, 6, 7. 756 pi. We told it to leave it in terms of pi. So that's that one done. Okay, we've got a vector problem now. Let's have a look. ACEF is a parallelogram. That's ACEF. B is the midpoint of AC. There's AC, B is the midpoint. M is the midpoint of BE. And what have we got to find? Oh yes, CB is a vector A, E to D here, vector B, and D to C is 2B. So this is going to be 3B up here. Let's just put a few bits in that we know. That's 3B up there. Parallelogram, so if that's the midpoint, this must be A as well. I like to label these things a bit so we know where we are. There, this must be 3B, being a parallelogram. And of course we've got 2A going that way, 2A going this way. Okay, what's our problem? We've got to prove that AMD is a straight line. All of this is on the same line. Of course, it's not shown, it's not accurately drawn, which is our normal way of doing these things. So before we start, I think we'll review some properties of vectors. So we're just going to have a quick look at that. Okay, one of the points to bear in mind with vectors is that they're different from scalar quantities such as mass. Mass is just so many kilograms. It has no other property other than that, really. Whereas a vector has both a magnitude and a direction, such as a velocity or something like that. A good example might be the speed of an aircraft flying at 500 kilometers an hour heading west, magnitude and direction. Now for this question we're doing, we need one or two principles of vectors, so let's look at that. Here's one thing, vector multiples are parallel. So let's mark out our vector. This is a vector, A, heading in that direction. Let's say it's heading east, and this vector here, B, heading in southeast direction. And that gives us a resultant, A plus B, heading in this direction here. Now we've got this other set of vectors. This time the direction heading east is 2A, and heading southeast is 2B, which we can show a resultant here, this red line, of 2A plus B. A plus B is parallel to 2A plus B. That's one of our principles. Let's move on to something else. Another thing, vector multiples with an identical point are on the same line. So we have these vectors 2A, 2B and A and B, and they could be anywhere in space, but these endpoints define where they are. So we've got this point starting at C, it could be a location or something like that. We're saying this other one starts at C as well, so it's not really in this space, so let's put it where it should be, and this one's going C to D. C to D is A plus B, and C to E is 2A plus B, twice as much, but we're saying that they're parallel. So let's have a look. Which I think we can see, if we now look at CD, which was from here, is now mapped onto this vector, and we can see that it is parallel, and D is the midpoint, which is what we would expect, because if CE is 2A plus B, then CD is A plus B, which is halfway along this point here. But more importantly, from the question we're looking at now, is D lies on the same line. All of them lie on the same line because they have one point in common. It doesn't matter which point it is. As long as there's one point in common, they must be on the same line because they're multiples of one another. One last thing to say is that a multiple could be a fraction, half times one set of vectors, or a tenth, or something like that. So let's return to our question and have a look. Okay, back to our problem. Show that AMD is a straight line. If A to M is a multiple of A to D, and they both start at A, they must be parallel and on the same line. So let's find A to D first. A to D. We can go any route we like to get to this. But we'll try this one here. 3b. It's minus 3b, isn't it? Yes. Minus 3b. And minus 2a. And then we add a b on, going up there. Plus b. Okay, and we'll simplify that a bit. That gives us minus 3b plus b minus 2b minus 2a. Take the minus 2 out. b plus a. And now we'll find our route from A to M. I think A to M. It's not going to be obvious, but if we go to A to M is going to be A to E. So A to E is here, and then if we go E to B and take the average of that, the half of that, we must get to M. Because, right, E to B, any route we like to take, the only ones we know is going up here and along there. That will be E to B. If we then have that, we must be at M. So let's have a look at that then. So that's going to be E to B and a half of that. So A to E first. Is minus 3b minus 2a. Can we simplify that? No, not at this stage. And then E to B over 2. E to B over 2 is going to be 3b plus a. Takes us that 3b plus a, and then we're going to have it to get to M. And I think the easiest way to show that is 3b over 2 plus a over 2. And now all we've got to do to get A to M is add these two together. So that makes A to M equal to minus 3b plus the 3b over 2, which will be, so it's minus 3 plus 1.5, so that's going to be minus 3b over 2. And this bit here is minus 2a plus a over 2, so minus 2 plus a half is going to be minus 3a over 2. Take out the common factor, minus 3 over 2, which will leave us with b plus a. Now that is the same as what we had up here for A to D. So A to D and A to M, they have the same vector group b plus a, and they differ by the multiple. One's minus 2 and one's minus 3 over 2. So we just show that on here, and if you were in the exam you would just draw a line like this, and I think you can just pop it in. You haven't got time to put lots of stuff in, but let the examiner know what you're doing. So this is parallel. And just end it with a sentence like this. AMD is a straight line because A to M, let's put that line in, and A to D are parallel as shown, so shown in there, common vector of B plus A, and they have a common point, they both start at A. It's good to put a sentence in occasionally just to let people know what you're doing. Okay, done, finished. Okay, we've got this question, 21. A, write as a single fraction in its simplest form, 5 over 2 minus x minus 4 over x. Well, this is a bit of algebra plus knowing how fractions work. So let's just do a quick reminder of how we do these fractions or subtract fractions. Let's have a look. If we go, call this A and B, and that's C and D. Well, the way this works is we have to make a common denominator, AB, and then we have to multiply B by C, like that, and A times D. And that's it. That's all we need to do really, and then probably simplify this top. So let's do that for this here. So it's going to be on the denominator, it's going to be x, 2 minus x, and on the top we've got 5 times x, and it's going to be minus 4 times 2 minus x. And then we need to expand this bit at the top there. 4 times 2, 8. Minus times a minus x is plus 4x. We'll keep this as it is on the bottom. We don't need to expand that. And that's going to give us, down here, how many x's we got? 5x plus 4x, 9x. Minus 8 over x, 2 minus x. Okay, that's that bit. Right, we now look at part B. Make y the subject of the formula. Well, nothing's going to cancel. We've got a y there and a y there. We can't just cancel them out because there's no common factor. What we have to do is move this lot to the top, and then we'll at least get rid of the denominator, and then we'll play around with it then. Okay, we're times by y plus 2. So that gives us t, y plus 2 equals 2 minus 3y. Expand this, keep it in alphabetical order, ty plus 2t equals 2 minus 3y. Bring all the y's to one side, take the t's the other. We do it in stages. Add 3y to both sides. ty plus 2t plus 3y equals 2. And then we'll move this 2t to the other side, so minus 2t, both sides. And we'll end up with ty plus 3y equals 2 minus 2t, and then we'll factorise this. We've got a common factor in y. And we've got a common factor in 2 here. Final thing to do to get y on its own is divide both sides by t plus 3. So we end up with y equals 2 1 minus t over t plus 3. Finished. And that go in there. Question 22. A, B, D and E are points on a circle. That's our cyclic quadrilateral. ABC is a straight line and EDC straight lines. Okay. Prove that triangle BCD, that's this one here, BCD, is similar to triangle ECA. ECA, so that's going the other way. BCD is going that way, ECA going that way. So for them to be similar, that's X. So that must be similar to this one here. And then this is Y. Okay. There's a couple of principles we need about cyclic quadrilaterals. The angles inside will add up to 360, but more importantly, the opposite angles add up to 180. So this one here, ABD, and AED will make 180. And this one here, EAB and BDE added together will make 180. So that's one thing. The other bit of information we need to know is about similarity. A similar triangle is similar to another one. They don't have to be the same size. The three angles have to be the same, but they can be mirror images, which is what's happened in this case. So this is a mirror image of this one, just a different size. Okay, let's put that information down. That will do. Put something like that down. The sum of opposite angles in a cyclic quadrilateral equals 180 degrees. One bit of information. And then triangles are similar when they have identical angles, but the triangle can be a different size and a mirror image or flipped over. I've gone over the top a bit there, but it's good to stress it. That's the two bits of information you need to solve this problem. Okay, let's do the rest of it. Let BAE equal Y. So this angle here, BDE, must equal, according to this, opposite angles in a cyclic quadrilateral equal 180 degrees. This angle here must be 180 minus Y. So let's write that down. And therefore this angle here, BDC, must be 180 minus BDE, this one here, which will get us back to Y. So we'll look at that. And for completeness, we can add in this bit here, angles in a straight line equal 180, which is where we got this bit from. And similarly, that's all that needs to be done for this question. And it's 5 marks. And one other thing, up here, this star next to it. So it's the sort of question which does need some explanation. So that's the end of this non-calculator paper. Hope you all found it useful, and I'll be doing a calculator one soon. Bye for now.